Very good evening, everyone. Today, it is the live session number 9 for the course named Chemical Crystallography, which has been taught by Professor Anshuman Rajoudhary from ISM Mohali. We have 3 more classes left since the exam date is 28th October and I'll finish by 13th October. I'm the course TA, myself Shani Burman. Excuse me. Myself Shani Burman. I'm the PMRF scholar in the Department of Chemistry, IIT Hyderabad. In week 9, Sir has taught us data, regarding the data reduction, the absorption correction or the Lorentz or polarization correction, then scale and temperature factor and all, and how to identify from the intensity statics of the correct crystal system and the presence of the inversion center or any two-fold rotation axis in the lattice. Coming to the problem solving, I have taken this from the last quiz, quiz number 8. The first one is what is the minimum value of D required for a publishable data as per IUCR guidelines. Just a sec. So for to get publishable as per IUCR guidelines, we know the 2 theta value. We have already 2 sources, molybdenum and copper. The 2 theta value for molybdenum is 50 degree and for copper it is 84 degree. Okay, and also the lambda values. It is 0.71 Armstrong and this is 1.54 Armstrong. So you can just detect the DHKL value from the formula in lambda equals to DHKL sine theta to DHKL sine theta. Hence, aim we are taking as 1 and then DHK. Acha, there is one term here which is given the minimum value. Here, molybdenum is having the minimum 2 theta angle. So the minimum value of D will detect by considering the source as molybdenum. And the DHKL would be lambda of molybdenum divided by 2 by sine theta. That is 0.71 Armstrong divided by 2 into sine. 2 theta is 50 degree, theta is 25 degree. But the minimum value of D it's written as so D is 1 by DHKL. And if you do this from here, so you will get it as 0.84 Armstrong. So the answer is this. And for copper, if you use copper source, this is for molybdenum, and if you use copper source, it comes around 1.2 Armstrong. Now, the next one is which among the following statements is true about the negative thermal parameter? This one I have already done in the last class. The negative thermal parameter it comes due to when atoms are not refined independently. The next one is the metal does. What metal does the beam stop has? It has lead because it absorbs most of the incident X-ray and it doesn't let the refracted beam to direct hit the detector so that it protects the detector. That's what the beam stopper that's what the function of the beam stopper is. Why the atoms are elliptical in shape and not spherical? Because of their thermal motions. Yeah, this one. It doesn't depend on the number of electrons or the interaction or with the any interaction with the X-rays. What is true for dynamic and static disorders? Excuse me. Dynamic disorders reduces with reduction in temperature, but static disorders do not. So this is the option. I have already done this in the last class as well. Like in the previous year assignment also it was there. That's why this question has come again in my PPT. Like though this is the same question if you have submitted your assignments, then you must have come across with this question in your assignment 8 or quiz 8. The coordinates of all the non-hydrogen atoms are refined with least square refinement. Yes, it is true. In a molecule, the atoms of same kind will have similar thermal parameters. Yes, otherwise they will come disorder. Only whole reflections are used for indexing. Yes, of course. Otherwise, you may not get like indexing will be very less, or that will let you know that your crystal may not be a good crystal, or you have not placed the crystal in a good way. So you have to go and check that again. Usable PXRD data can be recorded using both molybdenum and copper. No, we only use one source. So it's false. The PXRD and single crystal XRD data for a same compound should always match. Yeah, it should always match. Otherwise, like first we detect the single crystal structure and we generate the zip file from it. And from the zip file, when we synthesized the powder sample and they have collected the PXRD data, we match the PXRD data, means our experimental data, with the zip file one. So, so that you can use as a standard. Otherwise, how would you tell that the same compound has formed? So it will be true. It should always match, but sometimes it doesn't. But yeah, like sometimes maybe due to some disorder and all, it doesn't match really well. But there a bit of shift is okay, but not that it doesn't match completely. It has to match like 99%. What does data reduction do? Like one more thing, like intensity can vary. Intensity of the peaks can vary from the zip file and the PXRD data. Like you still can consider that yes, there are the compound has formed whichever single crystal you got, that compound in powder has formed, but the intensity is varied of the peaks, but the pattern should be the same. The next one is, what does data reduction do? It extracts information about this diffractive intensity. Disordered atoms usually have high thermal parameters. Yes, of course, because they're disordered, right? Heat plots are a better option for analyzing the population of a property. Yeah, yeah, it's true. Because it plots can like show you different with different colors and all. It is very useful and it is very helpful to understand the property of any sample. The next one is the diamond formation always involves a center of inversion. No, not necessary. It doesn't always involve a center of inversion. Let's say you have mm, so this is N. It was sick today. Sorry for that. So let's say this is behind and this is the front. Similarly, this is behind. This is the front. This is front. And this is behind. So if we dimerize this, let's say, then same thing will happen. It won't have any center of inversion. The next one is correct Bravais lattices can be identified from the diffracted intensity. Yes, it's correct. The next one is the linear velocity of the reciprocal lattice points is equal to the angular velocity of rotation of crystal along its own axis. The linear velocity of reciprocal lattice points is equal to the angular velocity of rotation of its along its own axis. Yes, it's the no, it's not true. The linear velocity of the reciprocal lattice points is not equal to the angular velocity of the rotation of crystals along its own axis. Lorentz correction is applied to all the reciprocal lattice points that are responsible for X-ray diffraction in all directions. Right. Yes, it's true. It's like Lorentz correction is a correction factor that uses the variation of the intensity of the diffracted X-rays due to the distribution of electrons in the crystal lattice. So this Lorentz correction will help you to get the accurate measurement of the diffracted intensities, especially the large scattering angles. Also, it will give you the step value of in the data collection process. So it's true. Now the next one is thermal vibrations vary inversely with mass of the atom. Yes, it's true. Heavier atoms tend to vibrate less, right? It's like the nature of law. And like at a certain given temperature, the lighter atom will vibrate more. It's the same thing. It's this phenomenon is described by Debye-Waller factor and all. It's true. It's just a common sense question. Now, the next one is we can indicate if inversion center is present in the lattice or not from careful observation of IHKL. Yeah, it's true. Yeah, it will be true. Okay, just 1 minute, I'll just drink some water. Hmm. Okay. Where were we? Yeah, here, where we? So this is true. We can indicate, yes, we can indicate if inversion center is present in the lattice or not from careful observation of IHKL. Next one is this is a sum for the 111 reflection. Given this, what will be the polarization factor if copper K alpha X-rays are used? Do you know what is the polarization factors? So, I'll just write. There is a one formula for X derivative. If related HKL, relative HKL, if HKL is structure factor, we can write it as pi HKL divided by L into P. And you all know L is the Lorentz factor and P is the polarization factor. And what is the relation between the P and theta? So P equals to, you also can write P equals to half of 1 plus cos square 2 theta. I have to check whether from this I can do this equation or not. Okay, solve this question in the next class. Moving forward, which of the following statements is not true? The direction of polarization of an X-ray photon can change as a result of scattering and diffraction. Yes, it's true. X-rays are absorbed as they pass through materials according to Beer-Lambert's law. Yes, of course, that's the absorption. As the temperature rises, the atoms execute decreased excursions from their average. No, it should be increased excursions, right? This should be the answer. This is not true. Now, what is the what is the slope of Wilson plot? Like this is very easy question. Like I can just like you should remember this always that slope of Wilson plot is always minus 2b. This is, I hope you know how it looks like. Let's say this is, now here we have extrapolated. This is the main plot, and here the slope is minus 2b in x-axis. It is sin square theta by lambda square, and in y-axis, let's write it y. I'll just do the equation here. Non I related by summation of f square, f naught square and 0 I equals to 1 to n, let's say. And so this is y equals to ln c minus 2b into sin square theta by lambda square. So this is the intercept. So this you can write as ln c, and this is your x, and this is your slope. Now the next one is, this is very common. Already I have you must have come across this question like many a times. Systematic absences do not rise from mirror plates. Right? So the next one is, which among the following is correct regarding two-fold axis parallel to the y-axis in the lattice? Okay. The presence of two-fold can be determined by the Wilson plot. Yes, it can. We'll observe. I observe my H01 divide R by HKL equals to 2. Yes, because it's parallel to y-axis, so here y is taken as 0. Now from Adamel's scattering data, yes, Z test of HO, H0 and reflections will demonstrate centrosymmetric distribution, while that of HK will indicate non-centrosymmetric distribution. No, this is not correct. Okay, I'll check these questions again. Next one is, which among the following cannot be improved once the data has been collected? Okay. Okay. From like looking only in the, I thought the this is the option, this is also option. Then here it is given both. Yeah, so both is the option. R int and R sigma. Once you have collected your single crystal X-ray diffraction data, it cannot be modified. Okay. So in this lecture, I have covered quiz 8 and let's say the practice sets of quiz 9 of both this year and last year's, and also last year's quiz 9. I'll give the answers of these two questions in the next class. Okay. So sorry, this is okay. This should be week 9, and I have to check this. The assignment submission deadline. When is the assignment submission deadline? 27. 2709. Okay. I hope you will be submitting your assignments on time. Okay. Thank you.